This is section 6.4, Solving Absolute Value Inequalities. This is day 2 of this lesson. Yesterday we worked on solving absolute value equations. So when you finish today, I expect you to be able to solve an absolute value inequality as well as graph it. So we're going to go through and we're going to solve and graph. So just like when we solved an absolute value equation, when we solve an absolute value inequality, there are going to be two possibilities. One possibility is what's inside your bracket right here, or your absolute value bars, is actually positive. So I could have x minus 4 is less than 3. And then we also have the possibility that what's inside here is negative. So we could have x minus 4. Now this is where you've got to be careful, because we'd say negative 3. Oh, but I changed the sign. So if I change this sign, I need to change the direction of the inequality. So I need to change the direction of the inequality symbol. That's the only thing that's different. So on the first one, I'm going to add 4 to each side. Negative 4 plus 4 adds up to 0, so now I have x is less than 7. Let's do the other one. I'm going to add 4 to both sides. So now let's see, negative 4 plus 4 adds up to 0, so I have x is greater than negative 3 plus 4 is 1. Now I know that my two key points are 7 and 1. So I'll make sure those points are contained on my number line below. So at 7, I know I'm going to have an open circle. And at 1, I'm going to have an open circle as well. Now I've got to look and figure out where I'm going to shade. So I'm going to go to 7. Where is x smaller than 7? Well, x is going to be smaller than 7 going to the left. Where is x larger than 1? Okay, that's going to be going to the right. So now I know that the solution for this inequality shades in the middle. What kind of statement do I have? I have an and statement. So x is less than 7 and x is greater than 1. Okay, let's solve and graph. 2x, absolute value of 2x plus 7 is less than 11. Once again, we have the same possibilities. 2x plus 7 could be positive. So I would have 2x plus 7 is less than 11. Or what's inside these absolute value bars could be negative. So I have 2x plus 7. Remember, change the direction of your inequality and then the opposite value, so negative 11. Now let's go through and solve each one. So the first one, I'm going to subtract 7 from each side. So now I have 2x, positive 7 minus 7 adds up to 0, is less than 11 minus 7, that gives me 4. Divide both sides by 2. So I have x is less than 2. Now let's look at the other one. Going to subtract 7 from both sides. So now I have 2x is greater than negative 18. Going to divide both sides by 2. So we end up with x is greater than negative 9. 2 and negative 9 are my key points, so I have to make sure those are on my number line. Now this time I went by 2, so I didn't want to have to make all those hash marks. I just wanted you to see that you could do it differently. So I know that at positive 2 I'm going to have an open circle. And I know that at negative 9 I'm going to have an open circle. So negative 9 is going to be right in the center right here. Now I need to figure out where I'm going to shade. Now x is smaller than 2. Was 4 smaller than 2? No. What about 0? Yes, so I know I'm going to be shading to the left. Let's look at x is greater than negative 9. Well, is negative 12 larger than negative 9? No. What about 0? Yes, so I'm going to shade to the right. And because these overlap, my solution is only going to be the area where the solutions overlap. And once again, what kind of statement? And. Okay, now we have 3x minus 2 is greater than or equal to 8. So once again, we have our positive possibility, where we have 3x minus 2 is greater than or equal to 8. And we have our negative possibility, where 3x minus 2 is less than or equal to negative 8. I'm going to go through and solve. I'm going to add 2 to both sides. So now we have 3x is greater than or equal to 10. Divide both sides by 3. So x is greater than or equal to 10/3. Now I could also rewrite that where x is greater than or equal to 3 1/3. Now this is a third, so I know I'm going to be able to graph that. I'm not even going to worry about writing that as a fraction. I'm sorry, as a decimal. Now the next one, I'm going to add 2 to both sides. So now we have 3x is less than or equal to negative 8 plus 2. It's going to give me a negative 6. Divide by 3. So x is less than or equal to negative 2. So my key points are positive 3 1/3 and negative 2. So I have to make sure those are contained on my number line. Let's graph negative 2 first. So I know I'm going to have a closed circle because I have less than or equal to. This little bar under there tells me I need to fill in my circle. So at negative 2, I have a closed circle. And then my next point is going to be at 3 1/3. Well, I like thirds because all I have to do is break this little piece in between 3 and 4 up into 3 pieces. And I know that my 3 1/3 is going to be at this first hash mark. And I also know that it's going to be a closed circle. Now I have to figure out where I'm going to shade. Now where is x larger than 3 1/3? Going out or to the right? Now where is x smaller than negative 2? Well, the numbers get smaller as I go to the left. So this one shades outward. What kind of statement do I have? I have an or statement. So on these, you're not going to know what kind of statement you have until you graph. Okay, last one. So we have our, what do I have to do different for this one? That's right, I can't just solve this one because my absolute value bars aren't over here by themselves. So the first thing I have to do is I have to rewrite it. I need to add 3 to both sides before I can get started with any of this. So then I have the absolute value of 2x plus 1 is greater than or equal to 9. Now I'm going to take into account my positive possibility and my negative possibility. So for my positive, I have 2x plus 1 is greater than or equal to 9. And in case what's inside my absolute value bars is negative, I have 2x plus 1 is less than or equal to negative 9. So now I'm going to subtract 1 from each side. So I have 2x is greater than or equal to 8. Divide both sides by 2. And that gives me x is greater than or equal to 4. Now let's do the other side. Subtract 1 from both sides. Now we have 2x, positive 1 minus 1 is 0, is less than or equal to negative 10. I'm dividing by a positive 2. So I have x is less than or equal to negative 5. So 4 and negative 5 are the key points on my graph, so I have to make sure those are contained on my number line. So I have x is greater than or equal to 4, so I know I have a closed circle at 4. And I know that x is less than or equal to negative 5, so I have a closed circle at negative 5. Now where is x larger than 4? Well, x is larger than 4 going to the right. Where is x smaller than negative 5? Well, numbers get smaller as I go to the left. And that's it. Now you really have to be careful when you have an equation like, an inequality like this, because you have to get the absolute value section by itself before you divide it up into its positive and negative possibilities.